Hello, and welcome to Live Coding with Gerph. I hope we've got some people here today. I am going to be doing some more coding on my disassembler debugger for RISC OS. The stage we're currently at is that we have two components. We have, well, three components strictly. We have the 32-bit disassembler DARM, and that does basic disassembly of 32-bit code in ARM, and that's a open source component that I ported to RISC OS. We have a second component, which is the RISC OS module, which is my section that I've added to that, which then does the actual disassembly and display as requested by RISC OS. Additionally, those are integrated together. Additionally, we've got the Armadillo library, which is another open source component, which we have integrated. Sorry, we're not integrated yet. We've now compiled for RISC OS. It was somewhat painful yesterday, last week rather, because it was a lot of C99 code that had to be converted down to C89. So, hopefully we'll be able to do some more work on that today. The plan for the day is to take what we've currently got as the 32-bit disassembler and ARM module and the 64-bit disassembler and merge them together to make one coherent module that we can use in RISC OS. That's the plan. So I've drawn some diagrams to show what we're doing here, because I thought by just explaining it is probably going to be useless. So here we have a little diagram. So this is what we've got right now in the module. We've got the DARM library. The yellow sections are external and the green sections are mine. So we've got the main DARM library. We've got an example program. Those are now compiled and working. And that's integrated with a bunch of components that make the adapters library, RODIS, and some other parsing and bits to make one debugger module. And we've got a testing program that goes and disassembles a single file. This also takes in a small internal library for floating point and testing that. So that's what we've got right now in the module. We've also got this 64-bit AArch64 disassembler called Armadillo, and this is what we ported last week. So this has got the library and an example program, and that's it. They're not integrated with anything, but they do compile. So that's where we're up to right now. So what I want to do is to combine these. That can be done in a number of ways. So my original plan was to be able to just link in the Armadillo library and use it in here. But then we've got the DARM repository that's got a module in it, and this that then links in Armadillo as well. That doesn't feel right. So my proposal for today is this second diagram, which is not quite big enough. Oh, I'm going to have to make it a bit smaller. There we go, that's better. Right, fits on the screen now. Right, so here, right, we have DARM repository. We remove all of my sections into a new repository, which will contain just my bits and the integration for DARM. And Armadillo stays as it is. So that will then give us the existing system, but working as two different components, one that is isolated and one which is integrating. And then we take Armadillo and we bolt that in as well. That's the plan. So we basically go and take the components we've got, split off the RISC OS debugger components, and then integrate them in such a way that they link in with the library, which is what we're doing at the moment anyway. And the same goes for the Armadillo. We then integrate that into there. Just getting to this point shouldn't be too hard, because it's just ripping things out and putting it into a new repository. So I'm going to go and try that. I'm not going to be clever about it. I'm just going to lift code and put it somewhere else. I could do repository filtering to sort of keep the history in there, but I find that that's going to probably hurt me more than, well, probably hurt my viewers more than it'll hurt me, because I could enjoy learning how to do that again. I haven't done it in quite some time, and it's all documented, but it's not nice, so I'm just not going to bother. That's the plan anyway. Fingers crossed we'll have something useful at the end of it. Never know, but we'll give it a whirl. Right, so let's replace these diagrams. We don't need them now. And have a look. So, if anybody who's not seen this before, we've got DARM over here, Gerph/DARM, which is the RISC OS version of RISC OS port of DARM. I should probably label that in the about string, shouldn't I? So, ported to RISC OS as a debugger module. It's not really a debugger. Okay. And whilst I'm at it, I'll turn off packages and deployments because we don't have those. All right. There we go. So now anybody coming to this can see what it actually is. And we have Gerph Armadillo. This is an ARM64 disassembler. And I've already labeled this as for use with RISC OS. Did I also turn off? I did. I turned them off. Ooh, I labeled this with topics, RISC OS and RISC OS64. Let's go back and do that on DARM as well, because that should have been done then. RISC OS and, yeah, RISC OS please, and RISC OS64. So, there we go. So these topics allow people to find things more easily. So you can click on RISC OS64 and you can see all of the RISC OS64 things that have been built. Some by me, some by Paolo, and have a see what you can do with that. Anyway, right, back to where we were. Additionally, we've got this task board that describes what we've actually got, which has got the thing that we're trying to do here, which is making it do AArch64 disassembly. Hopefully, we'll get through some of this today. It's probably going to be a lot of Git work, so we'll see. Hello, Anchor. Yes, this is a reasonably big project. It's not huge, but it did a few things, taking in a few different components. So let us have a look at what we've got. So here's the Armadillo, and here's Let me swap these around. Let's just put them the other way around. Hopefully this is all big. Oh, it's not very big, that text. Let me bump the text a little bit bigger. I think that's better, but they're about the same size, those two now. Yeah, maybe. Yeah, it's fine. If anybody can't read, then let me know. But if you're on a phone, you're going to have difficulties. I'm sorry. Okay, so here's where we are. So if I have a look in the RISC OS directory, in here we've got standard RISC OS format, C's directories, H directories, and the CMHG. If we have a look in C, we can see that there are these purple files are listed are the symlinks, and everything else in here that's white is actually my bits. Is that example on mine as well? I don't think it is. Let's C/example. I think that's one of their. Oh yeah, it is their example. It's just their example that's in the README file. So yeah, there we go. All right. So first thing we're going to do is we're going to build it and we'll see that it works. Because if it doesn't work, then we're starting from a bad point. So let's go and build this, make the library, export that. Oh, yeah, there we go. It's already exported, so all's good. And then let's make the, what other files have we got here? We're going to make the dis file, which is the test program. Test program is working. The one warning, the send printf, I just need to fix the header for that. I haven't done so yet. So that's that. And what was the next one? So this file, there's example. That builds as well. Oh, I should test it as well, shouldn't I? Let's actually run it, shall we? Command af32.disfile. There we go. There's this file of hello world. give it a moment to start the emulation. And yeah, we're just assembling that. Cool. It's not a very difficult program. It just prints out the message here and then the message here. All very simple. So let us start thinking about how to split this up. I think the best thing to do is to first create the repository and then just move things over to the RISC OS repository. So let us give that a whirl. And as usual, naming is the hardest problem. I haven't actually given this a name, this debugger. So, I mean, in the CMHG file, so if we go and oh, I didn't actually build the module. Let's build the module. Makefile module. There we go. Build the module. And then we can load it up. Paradev. Drop us to the command line. Load the module, rm32.debugger, and then we'll just do help debugger. So all we've done is we've just called it debugger, and it doesn't have any special names, which I probably need to give it one because we need to distinguish it from other versions of the debugger, like the one that's in RISC OS Pyromaniac and the one that's in RISC OS Classic. So, naming things. This is where I struggle. We'll give it a name. Let's work out some name, shall we? And the way to work out a name is to try and create a project, I suppose. Here we go. This is Gerph, and we will create a new repository. How do I create a new repository? New repository. Here we go. So this is RISC OS debugger. I know it's available, but what do I call it? I could call it Debugger C. I could call it Debugger 2. I think I'm going, because I'm not going to be, what's the word, egotistical enough to put my own name on it. I've spent many years putting my own name on things, but this time I think we're going to be a little bit more realistic about this. So let's call it, I don't know. Right, we'll call it Debugger C for now. And if anybody can think of the name other than Debugger Gerph or Debugger JF, because there you go. I think so Darren Salt's debugger is called Debugger Plus, which is fair because it does more things. Yeah, we'll call it Debugger C. I really don't like that name. RISC OS debugger module in C. Yep, there we are. That'll do. As I say, naming things is the hardest problem. Okay, so we've now got an empty repository. What I'm going to do is I'm going to create it over here. So this is my ports directory where I put things. So strictly, this isn't a port. It's going to be a set of new code. But let us create the directory. cd riscos debugger _c, and then we'll start moving things over. So git init, sorry. Actually, the very first thing we should do is just create a readme file. readme.d, no, that's not right. md. Oh, that's a comma. This is going to be one of those days. Instead of disassembler, can we call it a bit peeler? I quite like a bit peeler, actually. I mean, I actually kind of like that. Let's stick with what we got right now, but I'm liking that idea. Sorry, down there is where people are chatting. So if I look down there, that's where I'm looking at people chatting. Bit peeler. RISC OS debugger module in C. bit rework. I may go against that one just because it's a bit weird. But I like it. Just as a name, it's what the heck. Right, this is a RISC OS mod. Ooh, yeah. Today is not going to go well if my typing is like this, is it? This is a module for RISC OS which integrates to some open source disassembler module components. Oh, come on, into a RISC OS module. The repository is intended for use on RISC OS 32-bit and 64-bit systems. Okay, that'll do as a README for now. Add README and commit it. Initial README file. The repository will be brought over from the DARM repo. Let's just copy that URL. Copy, paste. Ooh, that overruns my line length. But here is just first README. Remote -a. Where's my repo? It's this one here. Next, this magic line here. Oh, remote add origin. Yeah, there we go. And then push. Bum, bum, bum. And if I reload that, apparently F5 isn't reload. It's novel. Okay, we have a basic repo there. Oh, I should also make sure we've got packages and deployments turned off, and RISC OS there, and RISC OS64. Okay. All my releases are done in DARM will be redundant. No matter, I can pull them over here. It's not a big deal. Okay. So that gets me just that. So now let's go and pull over all the bits that we did inside DARM into this new repository. So to do that, I'm going to use Beyond Compare, which is a merge tool, diff tool. So what I want to do is copy. Oh no, that's not the one. I went too far up. DARM RISC OS with here. It's loading. Dum, dum, dum. Let's put it off the screen. Here we go. Can you move back onto the screen, please? Right. So we've got very little in this. The left-hand side is. Oh, sorry, the text is very small here. I don't know. I can bump it any larger. Let's just have a quick see if we've got anything in settings. I think this is a useful thing for me to learn as well. Fonts. This is the what can we got next? Folder views, default text. How do I change the font size? Can I do that? System font. Turn that off. And then, then I can confirm a tiny little window popped up down here. English fonts, currently selected at size. Let's jump to size 8. Oh, it's live as well. That's good. Oh, that's not bad. Let me just bump it a little bit larger. Cool. All right. There we go. Ta-da! Right. See, this can actually be seen. All right. Right. So we need to move across all the bits that are RISC OS specific. So let's have a see what we've got in here. All the ones that aren't symlinks are mine. So, oh, that isn't. CTZ was needed on there for that. So that's RISC OS module specific. That's module specific. that's module specific. Example isn't. All of these here are. Ooh, except. Yeah, OS isn't either. That's fine. So all of those should go over there. And veneer as well. Cool. Alright, and then in the header files, same thing. Those ones. Jump registers all the way down. All the way down. Yep, all of those in fact go over there. I think. Yeah. We don't even worry about the object files and the outputs. Some assembler. We've got a tiny bit of assembler in there. Well, far too much assembler really, but we've still got some. Git attributes can go over, and the git ignore file because they're common. This file, FPA test, and module are all for this. And version num is for this as well. Dum 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 dum. And the CMHG file as well. Is that everything? I think that's everything. All right then. Let's have a see whether this will do anything useful. So close that and see what we've got in here. Some files. Excellent. Now, I want to know whether this will actually build. So what I need to do is try and build it here. So make the module. And I will say this will fail. This should fail because it's trying to link against things that don't currently exist. Didn't fail. Oh, right. This worked because we're linking against the shared library, which is this libdarm, which is good. That's what I wanted it to do. That is really quite surprising. Worked. I mean, I'm not going to complain. Common command GOS. Let's actually just test it works. I'll unload it. Help debugger. Oh, hang on, I've got no test files. I've got no test files here to test against. Hang on a second. That one there, please. Hello world. And these two here. Oh, no, not that one. Those are test programs. There we go. Copy them over. Right, so we have a look again. So if we do dump I, so dump the instructions that are present in hello world, and it's disassembled it. Excellent. That worked. That was easier than I expected. All good. Letters, status. Let's add all these files. Git add, git attributes, git ignore, all the make files, version num, all the C files, all CMHG, H and S files. And that should leave me with just the test files not being added. We should probably add the test file, actually, come to think of it, because it's really helpful if other people can see what we're testing. No, I'll just put it in the root of the disk, the repository. It's not a big deal. Right. There we go. Commit Mosaic. Added the RISC OS module integration from, what was it called? DARM. Module integration for the RISC OS DARM has been lifted wholesale from the DARM repository. Together with the DARM repo, we can now build RISC module. All right, good, and we'll push it. On the RISC OS coding session last night, I noticed that that people previous week had been talking about this live coding and saying that it was useful for people to learn a little bit about how to use Git. So I hope that is actually useful to people. I've tried to make sure I do the right things here, so you can see what is going on. So now we've got this window here that's in the Debugger repository. I'm going to create a new terminal here that's got the DARM repository in, because what we can do here is remove all of the RISC OS components. Test notes, what's that got in it? Notes for testing. Oh, that's handy. I might just add that anyway. Oh, except that no longer relates to this repository. It now relates to the other repository. I'll move it over. Test notes, slash disassembler, debugger, yeah, debugger C to there. Let's move that to there. All right. So let's get rid of RISC OS module specific things. So if we do git rm -f makefile dis makefile fpa test makefile not lib, no, module, the cmxg directory, all of the assembler. Oh, I've got a test code directory here. That probably should be used, shouldn't it? I will probably need to move that across as well. And then I need to remove all of the, not removing recursively without an R. All right, I'll give you an R then. Git remove and F. Oh, this is very painful, isn't it? C/ breakpoints, C/CLI, C/default. I'm leaving CTZ because I think it actually needed to build the library. Default CPU registers, dis file, yeah, C/dis file, fault info, FPA, star, introspection, C/IO, C/memory, Rodis, and C/veneer, and that should leave us with only a couple of things in there. Oh, I type remote. Oh, it's RM, not remove, you stupid person. Okay. Oh, I missed the OS one. RM -F, C/OS. Right. And now the H directory is probably very similar. So I'm just going to go and replace all the C's with H's. Very warm in here today. Just give me a second. I'm going to go and open the window a little bit. Oh, I'm cooking. There we go. Should hopefully get me a little bit of breeze. Hopefully I'm not. Yeah, it's the contrast isn't too bad. All right, this file isn't a file. I should have noticed this. Look, it's highlighted which ones aren't actually files. Fish is nice. Fish is the terminal, the shell that I use. But in H, oh, still got more. Git rm-f h/cpr gregs h/heads. And HS system control. Cool. H mod head did not match anything. Why not? I'm just going to take it out then. Oh, it's not actually a file in Git, that's why. Mod head is not actually. And I missed Git exception dump. Dum-dum-dum. Okay, so in the C directory we just have example and ctz, and in H we have those. Right, so let's remove all the build and built directories and all of the O files, and we'll build it again. So RISC OS amu makefile lib, make our library, export it. See how this does. This will tell us whether we've deleted anything we actually need. Well, that worked. Cool. Lots of deleted files. Awesome. To be fair, we should also build the example as well and actually see that it links, because if it doesn't link, then we've missed something. It links. So, hey, does it also run f32 dot not Armadillo example? Is it just called example? Example. It is called it's called DARM. I should have noticed from the output there. Stupid. There we go. That's all it does, it just disassembles one instruction, doesn't it? Just proving that it works. Right. So this repository now has a lot of deletes to get rid of those parts. Remove all the RISC OS module components. Moved to new repo. The RISC OS module components can now be found in the repository, this one here, copy, paste, there we go. This repository now contains only the DARM specific. And we're good. Let's push that, and we should have DARM being a lot more lightweight. So go into this directory, and you'll see there's a lot less in there. Oh, we've still got the debugger. I've still got some extra code in there. Probably don't need that. What's the test code? Oh, this allows me to build some test. Build message trans. We're not testing message trans. Did I just lift this code and not use it? I think I did. It looks like I just lifted it. Yeah, I'll probably have to fix that up, because that looks like it belongs in the other repo. Immediates. Oh, it actually just compiles a bunch of examples, instructions. Fair enough. That probably does want to go in the other repo. Yeah, we'll move that over as well. Okay, so RISC OS parts of it. let's go and move that code. Let's do the comparison again, and we'll just pull over the test code directory. Okay, there's test code moved over. Yeah, that's good. Nothing else I need to do there. I wonder, did we actually have any automation in this? I had some CI. Oh, look at this. So, yeah, this is meant to build me the different versions of the code. Now, the state we're at now is this. This is what we've got. We've got the DARM repository being pulled in directly. Oops, that's not very nice. What I could do is, instead of pulling it in directly, I could only use released versions of the DARM repo. So I would pull them in from the releases and extract the library that had been exported. I could do that. But if I do that, what will happen is I'll end up with to make changes that fix things in the RISC OS debugger module, I'll have to do a release of DARM, which is a little bit tedious. So for now, I think I'm going to submodule this and make it build it that way. I think that's a reasonable way to do it. I'm hoping that's a reasonable way of doing it. We'll see. For now, I'm just going to try and get them to build, and then I'll do the integrations that they automatically build in CI. But, yeah, what I've done so far is I've added in this test code. Let's go and add that. Git add test code and test notes. Actually, test notes can be expanded, can't it? The test simple testing. The test code directory contains an example binary which gives example registers or example instructions in different forms. This can be used to check the system is working properly. All right, there we go. Yeah, all right, let's do that. All right, so I can go and commit that code. As I added test code examples and notes. Alrighty. What was next? Push that is next. Next, so we are currently at this stage. Next bit is to try and integrate Armadillo library with the RISC OS adapters. That is this stage. Popping that arrow in. So let's give that a whirl, shall we? Close those windows. I didn't mean to close them. I wanted to keep them for reference. No matter. It's not the end of the world. Right. Let's have a look at Armadillo. So this is the Armadillo repository, and as you can see here, we've got a library and some example code. And this doesn't have any other integrations. It's only examples here that are just all from the open source project. So this is quite good. So if we make this as an export, not for 64-bit, just for 32-bit for now, make the library, oh, and export it, please. Okay. Okay. And then we go back to DARM here. This is, no, not DARM, the RISC OS component. Oh, I've not actually got the window open. I'm going to do a multiple. In fact, this is what we can do here. So let's close the Armadillo window and let's open. I didn't mean to do that, I don't think. It doesn't matter. Right, open RISC OS Debugger module. Hello, RISC OS Debugger module. Right, so then what we can do is we can go, oh, something I've done recently has caused it to lose the add new directory. I don't know what that is. I'll just have to do it from here. Add folder to project. You have to trust me on that. I was using the menu on the other screen. Go up. So that's add DARM. Now DARM appears down here, and then do it again. Whoops. Add project, and add in ports. Oh, I do want Armadillo. There it is, Armadillo. Open that as well. So now I've got RISC OS Debugger at the top, DARM here, and Armadillo below it. Likelihood of this working? Pretty low, but we'll give it a whirl anyway. So we'll start out with the dis file part, because that's the dis file we saw was the tool that goes and disassembles things. It's just a command line tool, and that's quite easy. So dis file, this one here, in addition to the DARM library, we'll also link in c:\armadillo.o.lib armadillo. Okay, so we're just linking it. We're not actually doing anything with it. Let's try it. RISC OS amu make file module. I didn't want to build a module. I wanted to build this file tool. Listen to what I was saying. There we go. Let's try that. It linked it, so that's working. It's working. Things that are working shouldn't really be a surprise. However, it's nice to see, isn't it? Now we need to use it, and I don't know how to use it. Fortunately, Armadillo does come with an example program that says this is what you need to do. So let's go and have a look at the example program. This is it here. Oh, they had lots of things in here that actually did lots of disassembly and things. They actually explained all of the different types of operations and stuff. And we don't care about that. We just want to use the interface. I just want to show the disassembly. Right. Display instruction, struct adds instance. You know what might be useful? Read the instructions. Is there actually anything in the README file? Oh, there is. They wrote it for debugger, lovely. The main structure is this. It contains information about disassemble instruction. So that's similar to the same thing that they've got in DARM. So it's got the decoded instruction and a whole bunch of other information. There are two functions you can use, Armadillo disassemble and then Armadillo done. So that basically turns the instruction that we've got into a structure, and then this one goes and frees it, I'm assuming. Takes it as a pointer and deallocates memory. Always safe to reuse an instruction after it is returned, even on error. It returns non-zero on an error. Okay, this looks cool, and it also means that we've got these immediate values as well. So I should be able to start appending immediate values quite easily. So Shall we give it a whirl? Shall we see whether it's working? I have no idea. This is going to be quite interesting, isn't it? Armadillo disassemble and Armadillo done is all we need. So in this file, all we do is we call into, let me actually open this properly. There we go. We call into, let's see, this file. So this file is a very simple thing. All it does is, oh, it actually allows us to dump a file as well. Oh, that's, oh, I didn't know it could do that. Oh, this is quite cute, actually. It actually does all of the processing in here. Lovely. Oh, which means we're going to need to insert the new 6 in here, aren't we? To do 64-bit. That one doesn't accept the command, the argument. We'll see. Right, well, let's just have a look at this part here. Yeah, let's just have a look at this part here and see what we can do. Yes, because dump is dumping the file, that's why, yeah. Okay. Parse architecture needs to be updated so it can understand that we have a new architecture available. Memory params doesn't, dump file doesn't, but disassemble file does. Okay, so first thing to do is parse architecture. Where does parse architecture live? It would probably be in RISC, the RISC OS disassembly library. Let's have a quick search. Parse archi. It's not. Where is it then? Parse architecture. It's defined in CLI part. Oh, it makes sense, yeah. Parse architecture. Right. So. This is interesting, isn't it? So let's let's go and do this. So here we go. 6 means arc. Apparently I've done it that way around. Instruction width is 4 bytes always. There we go. Okay, that's parse arc move, but I need to update the definitions that an arc ARM64 exists. CLI parser. Okay, let's give it one of those. Arc. Oh, cannot type. ARM64. It'd be nice if those were together, wouldn't it? But then those were the first ones. Yeah, that's fine. I'll leave it like that. I'll leave it like that. Included disassembly function pointer. Oh, that actually could be quite cute. That'd be the function you use to disassemble it. Oh, that's actually quite cute. Oh, that could be nice. Because in RODIS, in here, this one is for disassembling ARM and ARM64 and ARM32. Oh, yeah. So what I'm thinking is this disassemble word is actually disassembling an ARM or thumb word. So what we could do is if we create new functions here, let's give this a proper definition, shall we? Disassemble word, disassemble a 16-bit/32-bit word for ARM/thumb code, and word equals value to disassemble address was at thumb equals 1 for thumb code, 0 for ARM code. Just capitalize thumb as it's a name. Pointer to the disassemble string. Okay. So here's disassemble word. And that's the general version for DOM. Here, debugger disassemble has that there, but actually we want to wonder what that's used for. What we want is, what do we actually call in this file? Sorry, let's have a look at this. We call disassemble file. Disassemble file. Oh, where does that live then? Memory I? Yeah, here. Yeah, this is going to have to change as well, isn't it? Because it's not taking just thumb now; it's got other routines and other architecture information. Wouldn't it be easier if we actually just passed in the architecture here? So if we took the architecture that we got from this parsed arc block, and we just use that. Is that sensible? I think it might be. I think it might be. So, because the file accessor is going to be exactly the same. And then we disassemble stuff. That's a really helpful name, isn't it? But it also wants to be passed the architecture block. And then disassemble stuff. Just an awesome name. As I mentioned before, naming things is hard. That's going to need to change as well. Disassemble stuff here. What was the structure called? This structure is called a parsed architecture. Yeah. And that is a parsed arc t arc do. Instruction size. Why don't we actually have a look at what the instruction size is? Because we can. Instruction width. Yeah, let's just, yeah, so we'll use the minimum width for now. So it's going to be arc to, ooh, that should be a pointer, sorry. That should be a pointer. Should it be a pointer? Yeah, it probably should be a pointer. We should pass a pointer to it. So points to parsed arc. Arc to inst size max. When we come around to disassembling 64-bit AMD code, we will worry about min and max being different, or possibly 6502. I'll add 6502 at some point, just for the heck of it. So we've got the instruction size out of there now. There's the values. Disassemble word. See, this is where it would be really nice to just call the function. So we'd actually call arc to disassemble word, like that, and it just work. Word address. Actually, you'd want to do disassemble memory, and then do the address of that, and then I'll do it for now. Yeah. So the reason that I want to get the address of it is because if this is longer, you want to know how, oh, you also want to know how long it is. Yes. So mem size. There we go. No, not int size, mem size there. Which is int size, sorry. Okay. And then we call into, in fact, look at that. In the annotator code, that's exactly how we were using it. Typical, isn't it? We'll use it the same way there and there, and then that'll be quite nice. All right. So now we have to fix up disassemble memory, which was called disassemble word. So this is disassemble memory, and it takes. Oh no, that's the. Just got disassemble. It's easier. So this is I want different function pointers for each of the architectures. So there is a disassemble word memory ARM32, which will take a uint8 t star data, and then int data len, and it doesn't need to know its thumb. Disassemble memory ARM32. Work words for ARM code. Data points to the value to disassemble. Data len equals the length to the code. And then that's it, isn't it? Address is the address it was at. Yeah, and then we don't have that. So for ARM32, if data len is not equal to 4, invide len. Shouldn't happen, but we'll at least get a string out. Otherwise, we just return disassemble word for uint32 t star data address as ARM. Assumes data is aligned, which it is for now, but if we see odd problems, that'll be why. And then we have exactly the same code, but for thumb. Assembly 16-bit word, the thumb code. Disassemble memory, thumb. Invalid. If it's not 2, it's an invalid length. Okay, how does that look? And then we'll have another one for 64-bit. Nope, I've written 32 again. Arc 64. I've been using ARM64 in all the function names. I'll keep doing that. Yeah, right. Oh, hang on. The thumb one didn't pass in the thumb flag. This one needs to do it. So disassemble word should be DARM word. Oh yeah, DARM word. There we go. And then Armadillo. Actually, do we even need a word on there? Can we just do disassemble through Armadillo? That's better. Yeah, we'll lose the word off that because it's redundant. Okay. So I've just renamed that function. So this one here is going to have to change from being disassemble word to being disassemble DARM. There it is. And then we want exactly the same function, but for Armadillo. And because I've changed a whole load of code, I'm just going to not link it just yet. And I'm going to make it just return nothing. So here we go, disassemble Armadillo 64-bit, that's where I got my typo from. AArch64, we don't need this flagging of thumb. Crunchy on the inside, crunchy on the outside, sorry. Crunchy on the outside, smooth on the inside. That's right, isn't it? I think that's right. Because that is the correct disassembly, obviously, of 64-bit code. All right. Now, these few functions here, disassemble memory ARM32, thumb, and ARM64, need to go into the header of RODIS so that we can use them. Oh, yeah, look at this. Really unhelpful, isn't it? I'm not sure what this debugger disassemble is used for. I might have to change that one because it looks like it's probably not useful, but we'll see. Right, remove the code from this and just leave it as a prototype. Leave it as a prototype. Leave it as a prototype. Leave myself a note. And then I was also saying that the past arc thing here, so RODIS, so this is the one that needs to be passed in. Which was the one that was passing in the past arc? Don't know. It was in memory I, that's why. Oh, hang on. Yeah, that's right. This is passing in. So disassemble stuff needs to take a past. Oh, I need to update the declarations. Here we go. So this one here, disassemble stuff. Oh, disassemble stuff isn't actually exported. Awesome. If it's not exported, we can make it static. So that's good. And then what was the actual external interface? External interface is dumper file disassembly. Here we go. Oh, there's a file disassembly and there's a memory disassembly, isn't there? Yeah, memory disassembly. Dump memory. Here we go. Data width. That's dump. So this needs to take a past arc. Okay, so that needs to be updated in the header. Disassemble memory. Yeah. Update the header. Make it a prototype. And same goes for disassemble file as well. Dum, dum, dum. Right. So this has been a bit messy. I've jumped around a bit here, and we've got lots of changes throughout the code. So it's almost certainly not going to link with the this file tool, but that's okay, because what we're going to do is we're going to replace this with the architecture we're dumping as once we've decoded it. Where is it? Oh, past arc is only over here. Let's go and make it more global. There it is. And then past arc can get passed in here. Ampersand pass arc. Parsed arc, sorry. Right, this is going to have lots of errors. Yeah, lots of errors. Let's have a see what went wrong first, shall we? Lots of errors. Memory I, line 75. Oh, that's a header include ordering problem. So memory I, yeah, this needs to include the CLI parser. Because that includes the decoding of the architecture now. Oh, can't type. It should be parse, not parse. Try again. Mem declared but not used at line 73. Wrong file. What file were we in? Memory I. 73. Okay. No, because that's memory. You're actually reading from memory, so not a big deal. Yeah, okay, that's fine. Serious error, inst size max. Did I not? Hang on, what have I done here? Inst width max. Dull. So memory I, size max. Should be width max. Actual type int, mismatches format. Okay, not going to worry. I forgot something, line 119. If thumb. No, if inst size is 2. That should be. Yeah, that's right. Should never have been checking for thumb, should be checking the explicit instruction size. And then we haven't actually defined this disassemble function, which is okay because we can do that. We can go into the header for CLI parse and define one. So const char star disassemble. It's a function. It's a function, and it takes a uint 8t, the data we're decoding, the data length, and the uint 32t PC. Actually, that's probably wrong. Ooh, somebody's cooking something yummy. Well, it might not be yummy, but it smells yummy. Smells like roast beef. I want some roast beef now. Serious error. Legal cast of struct pointer. I've forgotten an ampersand at line 342 in memory I. 342. Oh yes, I forgot to put a pointer in there. I also forgot to describe it as. That's probably not been copied across then. Arc links to the architecture to decode. Let me just copy this into the declaration prototype. Disassemble file. There we go. Semicolon. Dum dum. One left. 279, 379. Wrong file, wrong memory I, this one here. 379. It's not thumb, it's arc now. Ooh, it looks like it might be doing something. Next file, what's broken on this one? Wrong number of parameters to disassemble Armadillo, and we're still calling disassemble word somewhere. All right. So 425 and 430 in Rodius. 425. Oh yeah, we don't actually have the flag on the end, do we? And this should be DARM now. And it's ampersand. No, it's the same as that one up there. So uint 32t star. So there we go. Doop. Oh, isn't that magic? All right, so pyrodev common command af32.dis file. I actually don't know how to use it, and we give it a file like that. In fact, it suggested it for me. So that doesn't seem quite right. That seems rather broken, in fact. I wonder why that broke. Stash. Rebuild everything without the changes I've just made. Okay. What does it normally do? It does normally work, doesn't it? Yeah, it normally works. Good. So that's nice. But why did it exit? That's really weird. So I can unstash my changes now, pull them back again. There we are. And then we'll rebuild. Disassemble hello world. It stopped dead. Why did it stop dead? What's wrong here? It's as if it just exited. Do we have an exit in any of this code? I don't know. How very odd. How very worrying. Yeah, very strange that. What shall we do here? Find out where it's going wrong, I suppose. We definitely should be getting as far as this function here. Config trace points equals disassemble _ star. I think that's the right syntax. See whether it works. So we called into disassemble stuff. And that seemed to be doing things. We went into disassemble file and that went into disassemble stuff, and then we exited. So let's go and have a look at memory I and look at disassemble stuff. Actually, what's probably a good idea is to clean this. So if we actually do clean, build it all fully clean, just in case we've got something that's pointing in the wrong place since we've changed some structures and things. Rebuild it. Now try it again. Still fails. All right, so okay. Disassemble stuff. We get the size. We read a block. We printed out this bit. We printed out the word. We print out the textual form of the instructions. We then called architecture to disassemble. Oh, that's never assigned. That's never assigned, so it will be calling 0, which is interesting because it should have really generated a branch through 0 error. Interesting. Or maybe a bug in Pyro for that. Anyway, let's go and assign that since that's kind of important. So past architecture to disassemble is what was the function called? I've forgotten already. It's in Rodis, sorry. Disassemble memory ARM32, ARM64. Cool. Not that one. This one here. Yep. ARM64, and then we just duplicate that to here and replace it with thumb. And then in this one, replace with ARM32. Okay. Rebuild. Oh, yeah, include the header. So we need to include Rodis. We might have a circular include here. Maybe not. I'm going to clean it and then just check, because if we have got a circular include, then we're going to need to move some structures around. Nope, all good. Run it. Woohoo! That disassembled it. Now, ask it to disassemble it in thumb as well. That's a lowercase t, does it? No, it doesn't work with that. Capital T, you have to give it the right case for that. Failed. Hang on, is that not the syntax? Oh, that's not the syntax. It's hello world, then the architecture. There we go. I mean, that's not valid code. Although thumb is so dense that it looks like valid code. I mean, that could be quite reasonable in some places. But that seems to have done it. And if I now select to do it as 64-bit, it'll come back with everything being, oh, invalid length. Ooh, interesting. That was not what I was expecting. That means oh, yeah, it's not 2 bytes, it's 4 bytes. Silly. Right, there we go. Rebuild that. Dum dum dum. And then 6. So we should get crunchy on the outside, smooth on the inside. Whoa! That's cool. Check out Raspberry. Yeah, I'm going to take a break very shortly. I'm just going to checkpoint this, I think. Rework disassembly interface. I've not added any new files, have I? No, it's all existing files. Right. Rework the disassembly place in advance of number of changes to the internal interfaces for the disassembly. allow us to disassemble more than just AArch32. So I called it arm and thumb. This means that many of the places where we passed a flag now pass a structure pointer which contains information about the architecture. Arm and thumb seem to work, but AArch64 is currently stubbed. And let's push that. That's available on the repo. Yeah, so we got that. It's now working. Ooh, suddenly yawning. Now I want to try throwing in the Armadillo code. Do I just want to throw it in and hope it works? Yeah, we'll just throw it in and see if it works. I mean, the phrase is, what's the worst that can happen? And hopefully nothing. Only I've forgotten how to use it already. So it had an example in the README that I kept lying around, this one here. That's what I do. Dead easy. Oh, really dead easy, isn't it? And it returns it says, this function returns non-zero on error. And you must always call Armadillo done there. Okay. Okay, that looks pretty simple actually. So we call, let's just comment that bit out so we can actually, if def disable able Armadillo. Oh, we can actually have disabling for Armadillo or disabling for DARM. We can actually have both of them being disabled. That's quite cute. So you can actually build a custom one that only supported one architecture. So it says non-zero on error. So fails equals that. The Armadillo disassemble passes in a word. Yep, that's right. Word. And an address, and this is a struct. This is a struct ad instance ad. We'll just call it ad. I think that's probably a good plan. Ad ampersand ad, and then we need to copy this, don't we? So we're going to need static. Let's give it a buffer of 256 again. Why not? Struct copy ad to buffer from ad to decoded. If fails, copy. What do we say? Do we say bad instruction, undefined instruction there? sprintf. Why do I sprintf it there? Should be a strict copy. No, it doesn't matter. Undefined instruction. A constant at the top. Yeah, that'll do. Instruction, another instruction. Dum 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 dee dum 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 dum. Where are we? Sorry for the burbling. %AD. Else return buffer. Ooh, apparently I missed an end comment there. Likelihood of this working? Pretty blooming low. Oh yeah, not even included the header yet. What's the header called? Is it called Armadillo? Include Armadillo. So those are two external libraries, and that's my library. It also probably means I need to update the make file to have a head. Yeah, so C:\armadillo. There we go. They need to be comma separated. Comma separated lists, so I need to pay attention. Implicit cast of pointer to non-equal pointer in two places. Struct AD instruction not defined. Oh, ADEFs wouldn't open. That means I need to also export the adefs.h file. Okay, let's go back to Armadillo. So Armadillo here, so the header, it also uses adefs, so I need to export that as well. So in the library, I need to export adefs. And make sure it actually gets exported here. Adefs. There we go. Okay, Armadillo is this window. And export it. And that'll copy the file out. Yep. Back to RISC OS module, and build it again. Oh, are we excited? I'm kind of excited. Dum dum dum. That would be a no then. Unrecoverable error in runtime system. Free failed. All right. Armadillo done. We passed in the value 28 and the value 0. That's odd. 28 doesn't look like a. Hang on. Where's? Hang on. Where am I? I want to be up here, don't I? So in Rodis, in the not the header file, sorry, in the C file, we were dying. We did disassemble Armadillo. Disassemble Armadillo here, and that took 2 pointers, which was the value 28 and 0. Okay. Word. Then we called into disassemble Armadillo here, which passed in 28 and the address 0. Might be right. Word address. And then when we called Armadillo done with the argument that value, it then failed. How interesting. Let me assign that to null to begin with, just in case that was the problem. You know, I could do both of these, couldn't I? That's correct, isn't it? Yeah, like that. You know, build it, and if it builds properly, run it. That's now working. It's giving me undefined instructions. It says all these are undefined instructions. So one of the interesting things is that many of these the ARM-like instructions come out as undefined instructions in 64-bit. Although I'm a little bit interested that these have come out as undefined instructions. That looks weird to me. That does look weird. Not quite sure what that means. I wonder if it means that I'm passing in the wrong thing. It does. Look, I'm passing in a uint 16 when I want to pass in a uint 32. I was passing in only half of the data. So build and run. And it'd be nice here to actually have some 64-bit code, wouldn't it? Because then I can actually see it working. Do I have a hello world 64-bit code? I think I do. Projects, RISC OS, Pyromaniac, test code, AArch 64, bin, hello world maybe? So copy that as hello world 64 FFC. What? Oh, not ls, sorry, copy. Right, if this works, then we'll commit it and we'll be coming back and testing it properly after the break. Let us see. Oh no, hello world 64, sorry. Here we go. Fingers crossed. That kind of looks right, actually. So we've got a header on this that indicates the module format, so the file format. It's telling us, I can't remember I'm going to have to look it up, I'm afraid, sorry. Let's go and have a look at the RISC OS 64 clib. Can you give me that, please? No, no. All right, thank you very much. That wasn't, there we are, simple binaries for RISC OS. It's now been renamed, but that's the one. And down here, it'll tell us the format of utilities. There we go, so there's an ARM32 entry, bitness and flags, so address 14 is 40, yeah. And then this is the offset, the ARM64 code. So address 5C is where the code is actually entered. 5C, stack some registers, give me an address, mov, call solve xy. Yeah, this is it, this is working. Right, so there's a bit of tidy up here because they're not lined up properly like we would expect, and there's some capitalization to do, and I think we can probably add some comments in later. But it's working! We now have an integrated Armadillo disassembler. Only in dist file. Only in dist file at the moment. Let's just be clear that this is only working in dist file. We've got to make it work in the actual module shortly. So, what do we do here? What have we got? This is... Oh, yes, we've integrated... added the calls to Armadillo to disassemble 64-bit code. We can now use this file to disassemble 64-bit code. This allows us to disassemble a very simple simple AArch64 utility. Oh, I should include the utility, shouldn't I? The utility is included. So commit that, add hello world 64, commit, amend. There we go. Same commit, but with that in as well. All right, that's now pushed to the repo. So if we do open, oh, that's going to open it down here. Not what I wanted. This one here. There is our repo. Oh, which was this one here actually, wasn't it? Yeah, it now has code in it, and we have a new branch that's got the actual working version on it. All right, so time for a break. 10, maybe 15 minutes because it's hot and I'm tired and my arms are aching. Hi, Alan. Yeah, so actually that's a very good point. I can now do a quick summary of where we're up to. So we're at a break. I have split off the RISC OS module parts out of DARM. So DARM is now just the DARM library that does ARM and thumb decoding. In fact, I had a diagram of this which I've lost. So I'm just going to have to quickly find it. Open, I think it's, yeah, open /projects ro talksite live. Yeah, just open that directory, please. Thank you very much. So this is this. So just to summarize, this is where we were. Dum dum dum. This is where we were. Oh, that doesn't look very good. Give me a second. I'll pop it up a bit bigger. Whee. So this is where we were. We had a very, very simple everything in one library. Green stuff is mine, yellow stuff is external. Everything in one repository. And what I propose to do, and what I have done now, is this one, which is splitting it up into, oops, that wasn't the right thing. Splitting it up into DARM repository. So DARM repository is just itself. Debugger repository is the RISC OS part, and we pull in the library from that. And what I've just done just a few moments ago is this bit here, which is to integrate the Armadillo library into there. So we've actually got all of it in there, and just demonstrated that you can then go and disassemble things. So I'll just show that, this file, there we go. You can now disassemble with the 6 modifier some 64-bit code. Oh, that's actually disassembling the hello world, so that's disassembling the old, oh dear, that didn't like that. Oh, escape not working right. Not sure what was gone, which bit went wrong. Oh, I'm in the process of reworking the escape handler in Pyromaniac, and I haven't reset it back to a good working version. So when I pressed Control-C, it did very bad things. So if I try disassembling the 64-bit Hello World, this is a utility that would print Hello World in RISC OS64, and there we go. That works. Woohoo! So this is all 64-bit AArch64 code in here that's being disassembled. It's not tidy. It's not done like I've got the formatting right, but it's working. So that's where we're up to right now. But this only works in disfile, which is the command line tool. I'm going to switch it over so that it goes and starts using it inside the module when I come back. It's all pushed to the library. The new repository is called RISC OS Debugger C, and that has got just the RISC OS part of it, and it pulls in other parts. Yes, so with that, I am going to go and take a break. Hope people will come back afterwards, but yeah, it's been really quite successful so far. See you in a bit. Bye. Hello, back now. Right, got myself a cup of tea, had a little bit of food, feeling a bit tired, so we're probably going to be, well, hopefully we'll be able to wrap some of this up pretty soon. However, you never know how it's going to go, do you? Could be a complete pain in the behind. Let us have a see, shall we? Right, what I said I was going to do was start integrating this into the module. And the way we want to do that is simple. We just build the module. Yeah, I was just trying to think what we would do that. Actually, it's quite simple, isn't it? RISC OS -f makefile module. Yeah, that's pretty much it, isn't it? So let's see what happens. Yep, it fails because all of the changes that I made haven't actually been propagated into this makefile. So this file here, compare them. So this is the dis file header here. So I need to include this, which is the Armadillo includes, and same goes for the libs. Ooh, that's frustrating. Why did I put them around different ways in the two files? Should we just swap them over? Put that there. Save it and recompare. That's better. Right. So yeah, it looks like clib is implicit on this. Why clib's implicit on one and not the other? Oh, my system is a bit weird sometimes. I think I just need to make things a bit more common. But yeah, just copy that over, remove clib, and we are done. Yeah, we're done. Yeah, that's it. Sorry, just confused us that is actually all it needs in there. Okay, let's do that. Let's clean first and then rebuild it, because I have changed some structure sizes and things. Okay, parsed arc declared but not used. That seems wrong in its own right. Let us have a look at that, shall we? Where are we? We're in veneer. So let's have a look at that one. That's line 153. Huh. Oh, yeah, we don't actually need it for that because a memory dump doesn't just dumps the memory. It doesn't actually do a disassembly, so that is irrelevant. That's cool. Memory A. We do actually do a disassemble here, so we should have an architecture before it. I think one of the things I'm going to need to do is, because external interfaces have right, this CLI parser here, this architecture parser, realistically I should have a function that can say set up for arc thumb, set up for AArch64. So let's create one of those. Set up architecture prepare. That's a better phrase. And architecture, past architecture for the okay. And what we want to take is arc ID identifier and a block to fill in. Yeah, block to fill in. returns bool true if successful, false if invalid. Bum, bum, bum. Prepare. Not really a past arc, it's now architecture info or something, I think, but I can change the terminology later. Cool. And so here we would call prepare architecture brackets arc plum. Oh, plum even. Oh no, I forgot the argument there, didn't I? This should be, oh, what type is it? I don't actually know. It's an arct. Okay. Case arc. What was the thumb? Yeah, sorry, it's right in front of me. Break case arc arm. Is it arm or arm 32? It's arm 32, and then there's another one for arm 64 as well. Oh, very sorry. Apologies. Didn't get to mute things, I'm afraid. Sorry about that. As well. 2 break. Now, this is kind of interesting because if we're in RISC OS 64, the default is here. And if we're in RISC OS, if we're in RISC OS 32, the default is, oh no, the other way around. No. This one, if we're in 64-bit, and this one if we're in 32-bit. We need to just get this second bit here. Same style. There we go. If we're not 64, we're in 32. Yeah, that's right. Bum, bum, bum. Yep, that looks okay to me. And that probably also means that we want a arc default as well, like that. For now, that'll do. If arc ID equals arc default, Actually, this is stupid. Why am I doing this? We don't need to do this, do we? Because what we should be able to do is just say, select the default. If it wasn't any of those things, don't step over it, but just select the default. And then put the logic into this function here. If def RISC OS64 arc ID arc ARM64 else ARM32. Default. If we don't get any of those, we return false or failed. Otherwise, we return true because we were successful. Right, this function here needs to now be. We need to include stud bool. Okay, pick this up and put it into here. And includes stud bool there as well. Okay, so that gets us the prepare architecture function, which is still warning me. What's it warning me about? It's happy now. That's good. And parse architecture has become simpler, and all the logic for what the default is now in here. That's much nicer. Yeah, so that's all in here. So now let's build it again. Just I've lost track of where I'm up to. I'm feeling stupid. Duplicate definition of parse architecture. What? Prepare architecture. Did I not? I forgot the semicolon, that was it. Yeah, okay, there we go. Undeclared name, parsed arc, and prepare architect. Dear me. Yes, I should call that parsed arc, shouldn't I? Because that's the structure name. Okay. And here it was also telling me that I've forgotten to put these things in. So I'll pass the wrong parameters to these. There we go. You know what I'm going to do? I'm going to git move make module to make file there, and then I'm going to use the build system to build it and give me the warnings, and then I don't have to be jumping in and out of the terminal so much. Oh no, that doesn't work because I'm exporting different libs. Alright, I won't do that then. That's frustrating. That's quite frustrating. No matter. Yeah, maybe I need to think on that one, how it's going to work in my editor. Build it again. Oh, except I move the file. Right, I'll move it back then. Good. We've built one file. On to the second one. Warnings, invalid pointer, so that's in veneer. What are we looking at? Line 227. Disassemble memory. Right, hang on. So this, hello Arctic. This is memory A. This is the one that modifies instructions. So we do need a parsed architecture. However, it only ever makes sense to pass the architecture that's in your current system. So this should be prepare architecture for the current architecture. Oh, no, hang on, you don't do it that way. I'll do it here. Prepare architecture for arc default into past architecture. There we go. Memory A only makes sense when writing instructions for the current. Okay, so that's good. Half word, word. Then there's this disassemble memory call. I think that was the one it was complaining about. Now, disassemble memory is one of the ones I changed. So what did I actually do? Oh, hang on. Memory I, this header here. Disassemble memory here. So this is the one that I changed, and it now takes the architecture pointer as the first thing. So, wrong one. No, this file. Yeah, this file. So this was inferring the fact that we were thumb by using the data width. Actually, data width here. Yeah, so we should be using the current architecture. So that's past arc there. And we should only be trying to disassemble it if the data width is greater than or equal to past arc to inst width min, and data width is less than or equal to past arc inst max. Let's just tidy that line up. Better. Right. So now it'll only disassemble it if it's the right length. So if you pass in a half word, it'll try and disassemble it in thumb mode, but not the others. Cool. Arctic says I should try Linux so I can be hardcore. This is a disassembler that somebody else created. It's an open source one called DARM, and another one called Armadillo, and I'm integrating them into a RISC OS module so that it can do disassembly of both ARM64 and of regular ARM 32-bit code. So that's what I'm doing here. So I'm writing the C code to produce that debugger at the moment, and it's nearly there. Yeah, that's what I'm doing right now. If you spin back to the earlier part of the presentation at the very beginning of this session, I introduced what was going on here. Yes, I'm cross-compiling from macOS to RISC OS because that's always fun as well. Line 288, illegal types for operands. Is that because it's a dot, that's why, yes. Because it's not a pointer at this point. So this disassembles, it turns machine code, compiled code, or assembled code back into disassembly. I'll show you a quick example. So anybody who's missed this as well, here you go. So this is what it does. This is running through my emulator, so it's a little bit slow. And here you go, it's disassembling. These are the instructions. This is the address. This is the text it looks like, and these are the actual machine code assembly instructions that are intended by those things. And so I'm now trying to integrate it into the rest of the module. Right. Build that one. Oops, build. There we go. I hope that makes sense. Legal cast of structor pointer, 231. Oh, yeah, because I should have an ampersand there. This is a pointer. Sorry. How to feel stupid. There's no further disassemblies there. More breakage, lots of warnings. Implicit cast of non-zero int pointer, 328. 328. Yeah. Ah! Oh, this is handy because it's actually passing in. It already has a past architecture object there, so we can just pass that straight through to it, which is cool. And what was the other line I was failing on? 367. 367. Again, another one where we can pass in the architecture to the file. Oh, it's nice when things are coming out nicely. This one looks like, I'll look at the warning in a second, but this 582, oh, it's the same line, 582. So Artix asks, do I think that Golang is a good language for low-level stuff? I'm not sure that Golang is. Golang's really useful for microservices and the like. I've never seen it used for low-level things, but that's largely because most of the things that I've used have been quite high-level for Go. So like rclone is in Go, and yeah, rclone's in Go, Terraform was in Go. What else did I use that was in Go? Can't remember. Mostly, I think Rust is probably your right language for doing low-level stuff. I'd love to learn Rust, but I haven't got around to it. One of my friends is doing that. So Paolo is using Rust to build some really interesting things. It would be really interesting to see how well Rust would work with RISC OS things, but I haven't spent the time on it, unfortunately. It's a lot more complicated. 582 is what I was up to. So I hope that answers your question. Anyway, I don't know much better than that because I haven't spent any useful time with Golang. I have written some code, but not a huge amount. Right, this disassemble word. So this is So this is disassembling your current architecture as a system call. So what I need to do here is to git, so past arc t start I need to prepare architecture arc default into past arc. It might be useful to actually have this prepared in the init code, but we can look at that later. And then pass that in as arc there. And disassemble thumb. Right. This one is explicitly using thumb. That's why we're not especially thought out, I don't think. Here we go, thumb. And that passes in RISC arc. So Arctic asks if you can assemble as well in reverse. This code doesn't do the assembly. I may start looking at that in a future project, but I'm only looking at the disassembly, decoding from bytecode into mnemonics. Remember the words there. My brain is not completely with it. Right, let's see how well we're doing now. Another disassemble word. Oh, because it's not called disassemble word anymore, is it? Is it in here? Disassemble word. Disassemble memory. That's just block of memory. Rodis was Rodis where we had disassemble word. I don't know anymore. I'm confused now. Where did disassemble word live? Was it one of these? I think it was one of these, wasn't it? So I wonder if I just need a switcher function that does all three of them. Yeah, we'll do that. We'll put a switcher function in here. Disassemble a word for one of the architectures. Oh, hang on, no, I'm stupid. I don't need to have a helper function for this. You just call the parser. You literally just call the parser. Do you ever recommend any programming language for making another programming language? Oh, yes, it's quite orthogonal to what I'm doing. Making other programming languages, C is quite common, but it's not the good language for that. C++, Java, Go has been used to good effect. There's a lot of programming languages these days are actually written in themselves. I believe Lua is actually written in itself. Is it Lua? No, I don't think. I mean Lua. Lua was implemented in C. Scheme? I think Scheme's implemented in Scheme. There's some others like that are just like, okay, that's confusing. But I don't do a lot of creating programming languages. I tend to be just wiring things up myself, unfortunately. So I haven't had a lot of experience of that. Sorry. And I've forgotten where I am now. I'm good. What was I doing? So I was looking in Veneer. Disassemble. Right, yes. So this is simple because it's passed arc to disassemble and then just pass in the parameters. Yes, a lot of them are written themselves and they're bootstrapped that way, which makes it very difficult if you're porting to another platform. I worked recently with Seafront, which is the ancient C++ system, and it's written in C++. But if you don't have a C++ library, it's a real pain to make work on the same system. So yeah, that's a fun bootstrapping problem. I've not fixed that one myself, but one day maybe. Right, so here's my list of architecture IDs, and these are different to the ones that I've got in my CLI parser here. So I need to tweak this list so that they come out the same. Note, please keep this list the same as the architecture. Oh, I can't spell. List in Debugger disassemble arc. Okay. Dum dum dum. 0 equals 2. Oh, sorry, equals 3. I apologize. 64 goes there. Equals 1. And I've set aside a value for x64. Should we be? We'll call it x64 because if I call it AMD 64, it's going to get confusing. Okay. And we don't currently support ARM x64. I could build in one of the libraries for that, but that's a whole other problem. If arc equals my here we go. You see, now what we can do here is we can get past arc to arc and decode the architecture ID. So we do past prepare function of architecture. What? Prepare architecture. Prepare architecture I've forgotten the call. It's in the CLI parser. ID and then the parsed architecture, and it returns true or false. So we go back to veneer again. All failed. No. Hang on, what did I return? True if successful. Okay. Okay equals prepare architecture arc, which is actually an arct, and return it into parsed architecture. So we don't need to do this magic here, and we can explicitly set the architecture to be parsed arc to what was it called? I've forgotten already. Arc. Okay, that's a pretty good name. But we only want to do this if it's successful. If not okay, what do we do if we fail? I think we have an error condition at the end. Yeah, we return unsupported architecture here. Unsupported architecture. Oh, this is fun, isn't it? Oh, you know what? This is actually very simple because it's going to be coming out very, very similar. So word size is going to be, let's just say it's going to be the parsed arc to inst width max. So when we come to handling variable length instructions, we can change all of this code, but at the moment the interface allows for it, but nothing else does. So if it's less than that, it's buffer overflow. If its word size is 2, then get 16. Call parsed arc disassemble with the word and the address. Don't need any other data. And that is it. And this is true for all of the architectures because it's passed the unsupported test. Everything is good. Oh, I'm feeling good about this. I'm feeling good about it. Let's see what the compiler feels about it, though. Compiler's less happy. Yeah, Arctic's talking about his language that he's written in Python. It's interpreted, which is quite fun. Yeah, that would be quite nice to be able to do. I haven't written any languages in years, but it's quite fun when you can get other people to try using it, particularly if you've done it as a learning exercise. You find all the odd little problems that come up, because there's bound to be little problems. Oh, that's what I've done wrong. That should be dot. That's what you get when you're tired. How are we doing for time? It's 3:30, so I think once I've got this stuff working, we'll be calling it a day. We're nearly there, though. 585, function typicast of non-zero int to pointer and wrong number of parameters. Well, that's broken. 585, let's have a look. Oh no, because this is meant to be word, comma, word, oh no, wrong place. It's a pointer to the word and the size of it. So this is going to be, the size of the word is going to be parsed arc dot inst width max. There. And that's going to be exactly the same code as this one. In fact, these two functions are exactly the same, excepting the architecture we're decoding. It's quite cool, isn't it? I wonder if I should make them common, maybe another day. And I've probably done the same thing here, so this should be ampersand word and word size, because we've already extracted that data. Actually, strictly, we don't need to care, because this doesn't matter here. We don't need to put it into a word. We've been passed the data. We've been passed exactly what we want by the user, because I designed the interface that way. So word size, this here is needed, yeah, but we don't need that. All right. How bad is this going to go? Oh, still, what? Inst width. Oh, it's instra, not 855. Yeah, my memory and brain are dying, I think. And that should be a dot there. Okay, let's just quickly try that. Still got it wrong. Implicit cast of pointer is an unequal pointer. What are you complaining about? Oh, because that's meant to be uint 8t. Yeah, that's why. And that'll be the fault of the other one as well. That's interesting. Okay. Compile that, please. And now we're getting to other bits, right? 681. Yeah, again, I should have a dot in there. And the other one was inventing WADRA, word ADRA. We didn't need word because we don't actually extract the data anymore. What ADRA is? No, that should just be ADRA. Not sure why that's. Oh, I probably inserted it by accident. I probably pressed a W at some point. That's probably what went wrong. Ooh! How exciting! One, two, three. Common. Load module rm32/debugger, and then drop me to a command line. Let's just see whether we've got something working. Oh. Come on, thank you. Dump hello world. Okay, can you disassemble that? You can. Good. That's quite nice that it actually does work slow, but it does work. Help dumpy. So what's the syntax on that? Oh, I've got to change the syntax, haven't I? Because that's not the syntax anymore. Just going to fix that now whilst we're at it. Because all of these commands are going to have different things on them. They can take T or A or 6. Or 6. Okay, so that'll be fixed next time around. So we do dump hello world 64 as AArch64, and it's working. It's disassembling it as 64-bit. It's nice when things work. I mean, I don't know what most of those other instructions mean because they're not like really valid, but they're not. It's trying to disassemble text, but squash loop on vector floating point registers. That's kind of magic. Anyway, so that's working. Next thing is, what happens if we do memory I? So memory I of actually load hello world to address 8000 and then disassembling memory. So there we go, that's the being assembled in memory. That's working. And now 6, that's the syntax, isn't it? Yep, that's working as well. Now let's try the test code. Oh, hang on, I could have done it from there. I could have done it from there. Stupid. Right. Test code is called Debugger, isn't it? Yeah, there we go. So if I do Debugger H, right, so I can just test ARM debugging. Yep. ARM debugging is working. Cool. Sorry, what was the other ones? And here we go, the disassemble arc call. I didn't write any blooming help, did I? A sequence of hex values for input. Okay. Is this what's in my test notes? No, it's not. Oh, that's a pity. Oh, let's have a look at how you use it. I just don't remember how you use this, which is just, I'll write it into the test notes once I've done that. So Pyromaniac, test code, test debugger, Swise, I think. So this is this is how you use it. Okay, so what I'll do is I'll just pinch this chunk of code here, and then we'll put that into our README for the test code. Where's it gone? I've lost it. Test notes, here we are. Right. The test code for disassemble AArch. Let's give that proper debugger. Disassemble arc can be triggered through the debugger test tool. Example commands. Disassemble an overlong ARM sequence. Next one. Disassemble a short ARM sequence. Next one. This is AArch64 sequence. Oops. disassemble a invalid architecture. An invalid architecture. And then this one here. I'll automate these at a later date. Right, okay, so there we are. Let's give some of these a whirl. Go back into the command again. Where's it gone? There. I could have left it running. Oh, achy. Right. Here we go. Disassemble an ARM sequence. So this was working before, should still be working. That looks good to me. Disassemble an overlong sequence. Again, was working before, should still be working. Invalid length. Invalid length. Okay. I think that's wrong. I think we should be returning. Data length is less than that. If data length is less than the word size, input size is 6, output size needed is 15 bytes. Disassembly, invalid length. I'm going to come back to that one because I'm a little confused. I may need to tweak it. Yeah, I'm going to come back to that one. And that probably means that the short one's going to fail as well. Let's try the AArch64 since that was the goal of today. Invalid length. What? I'm going to clean and then rebuild just in case something odd has happened, because I'm pretty sure I did just renumber the oh no, I don't need to run it. I don't want to run it just yet. Build it, sorry. Ooh, up to 27.5 degrees in here. That's why it's feeling a little uncomfortable. That's what we have a fan for. Ah, that's better. A little bit. Better. Yeah, there we go. Right, let's try that again with that command. Oh. Better. Right. And that looks like the right instruction as well. Right, invalid architecture. Debugger does not support the requested architecture. Correct. Disassemble thumb. We disassembled some thumb code. Alrighty. Yeah, get status. Where are we up to? Oh, I'm still in RISC OS. It's fine. Let's drop out of RISC OS. I can use Git in RISC OS. It's just not very sensible. Yeah, so I've tested that. I've tested DumpI. I've tested MemoryI. I've done the debugger architecture. I've done the regular disassembly, so that's worked with the current architecture. So now what we need to try is building it for 64 bits. Build 64 equals 1. This is not going to work, is it? And Talia says you have lots of fans. Ugh. Hello, fans. Hello, fan. I'm not very funny, I know. Why did that not build? Do we not export? We must export done. Oh, I haven't exported. Yeah, so DARM itself, library export for 64-bit. Come on. You're being a little slower than normal. The text is also a bit small as well. It's a bit big. Yeah, that's the same size. Right, so that's exported, and I'll need to do the same here. Build 64 as well. Oh, I'd already done that apparently. Fair enough. Build the module again. That is not the directory I wanted it to put it into, but okay. Well, maybe it is. Export lib. I don't actually know where it puts things for 64-bit. That is very surprising to me. I'm not quite sure. DARM. DARM. That should be there. Surely. Surely. That should be working. Well, I thought that should be working. This looks like a build system problem rather than anything else. I think I know what the issue is, but bum 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 bum. So it was working before. It's not working now. I'm certain this is a build system issue and I need to tweak some of the code a bit more. Oh, it's a bit of a pain. I didn't really want to be doing that. Yeah, I'm gonna have to think about this one. It's a little bit of a pain. Okay, so ouch. I'm going to call this good enough. I haven't actually got the 64-bit build of the module working just yet, but that is purely down to a build issue rather than anything else, and needs a bit more cleverness doing with it. I know what to do. I think I know what to do. It's just probably going to take me a week to get the blooming code working. The reason it's not working is that we actually transform the RISC OS format C and H files into the format that the compiler will accept, which is blah.c and blah.h. But when it comes to includes, the include directories, that isn't done. It only does it for the local directory at the moment. I started doing it for the other directories, but I haven't got round to it yet. So this has got a whole load of extra bits that are going to need to be done, and I'm not sure how easy that's going to be. It's going to be fun anyway. Bother. Yeah, I was hoping I'd be able to get the module out and working today, and I don't have a quick, easy fix for this one, I don't think. Actually, maybe I do. Maybe I can just... No, I don't. No, I don't. Or do I? No, I don't. I could just quickly try it. So if I just try copying the files into here, just to... It isn't completely correct, but let's just go with it for now. darm/h/... Oh, sorry, RISC OS/h/... I almost certainly will have received emails telling me that the automation, the CI is broken for things in this version, but that's fine. H. Okay. I'll do it this way because I think that's a symlink and it's not going to copy it otherwise. Yeah, that's right. Make the module again. I think I'm going to need to do the same with Armadillo as well. Oh, there's more files. Let's just... B7 double 7 double... I wrote 6 there. I meant 7. Yeah, I'm not feeling confident about this. There's a lot of files I think it's going to want. Armadillo, right, okay, this is good. We're getting somewhere. Armadillo. Oops, no, that's... Armadillo. And I know it needs ADEFs because we had to fix that up earlier. Oh, I had to fix that up, but I don't think I committed it. That's a good point. I probably need to go and do that. Okay, let's just do this. Oh. Well, that was kind of impressive. PyroDev 64 load module RM64 debugger, and then drops the command line. Do it. Okay. Are we going to work? We've got a command line. Good. Dumpy hello world 64. Now it should have automatically selected that that is the architecture to use. All right, so we've got this not working. It's not working in an interesting way because that's not the right string. These are all, no, those are correct though. These bits are right. But that should have been ADRA or an and something, I think. That might mean that we just didn't build it right. It might have not been built. Let me just clean the 64-bit build and rebuild it and see if it works. That's correct, yeah, Anchor. I'm not expecting it to be worked on. It's just one of those things. I don't know if they said it was no longer maintained, but it doesn't really matter. It's still a working library. End up maintaining it. That's what open source is for. Bytex has said, how since when have I been programming, and what's your favourite language? So I started doing programming back when I was probably second year of primary school, maybe, yeah, second or third year of primary school. So I have no idea what year that is. What's that, like 8 or something, 7, 8? I don't know. Might be a little bit earlier. Can't remember, can't think. And I'm old now. 48. I think I'm 48. And what's my favourite language? Well, the favourite is difficult. My current main language that I use is Python, but I have a fondness for C, ARM assembler, Perl, the occasional bit of BASIC. And there are languages that I really dislike but have to use regularly, things like Groovy, little bits of Java, obscure C++, and Lua now and then. But the language that I like is usually the one that does the job for me, and the ones that I don't like are the ones that keep biting me in behind. Things like Groovy really hurt at times because there's a lot of hidden behaviour that you're not quite aware of. And that's also true in Perl and in Shell and in C as well. But it's what you know and what is the right job for the right language for the task. Okay, so I've exported Armadillo. I'm going to go and rebuild this and see whether the module again and see if it builds okay, and then we'll run the test again and see whether it actually disassembles things. I mean, it was disassembling things, it just wasn't quite right. And I think that probably just means we've got some memory access issues. Yeah, that's not right. That first instruction there should have been something different. Should have a mnemonic at the front, and I don't know why it hasn't. Might be broken, of course. The other thing that Anchor said about the JVremner library not being maintained, I've already had to extend it quite a bit because it didn't support certain instruction forms. It didn't support, what didn't it support? Oh, MSR and MRS weren't supported at all, which was, they were kind of supported in the back-end table but not in the front end, so it could never actually decode them properly, and I had to add a lot of extra bits in there, but it is table-based decoding, so that's not too bad. Right, it's not correct, this, because obviously, as I say, this has come out with the wrong instruction, but it has produced something that is pretty much okay. So also, if I was to go and do the ARM version of that, there we go, that's the hello world in ARM. So that's good. Let us do some committing, shall we? Diff. Oh, yeah, that looks like what we've done. Okay. And I've added some more to the test notes, that's good. There's a few headers there that we don't want. These headers, we don't want to commit those, they're just here because I couldn't get the build environment working. So, added support for disassembling AArch64 or AArch32 or thumb. I think that's the distinction I've been making. AArch64 is the 64-bit side of it. AArch32 is ARM and thumb, and ARM and thumb are two separate instruction sets. That's confusing. We can now disassemble AArch64, ARM, and thumb with the disassemble AArch, or disassemble only was one S, or star memory I or dump I. The debugger underscore disassemble again. SWI now uses the default architecture. So in RISC OS64 it will disassemble 64-bit code. The disassembly for AArch64 doesn't seem quite right when hello world 64 with clear Y, maybe memory lifetime issue. Okay, the AArch64 isn't capitalized or formatted properly, cleanly. All right, that's good. And I'm going to declare that I'm happy with that, so I'm going to go and merge it into master. And rework. It all worked quite well. Yep. I'm going to go and increment the version number as well because this is working. And so that's a new feature, so we put the version. Go. Let's push that. Let's pop over to Armadillo temporarily because I think we had, yeah, we made a change to that. Yeah, -a and export of the adefs.h file. That as well. Right. So today we have done the integration of Armadillo into the debugger. So it looks now like this, with the DARM repository doing its bit, Armadillo doing its bit, and we're doing our bit, pulling them all together. And that seems to be working. That's pretty cool, and we can also disassemble AArch64 through the testing tool, and we have been able to demonstrate it working. One final thing to do, so if you ever look in, I want to build it actually, build it for 64-bit, and then build it for 32-bit as well. Interesting. Oh, did I just do an export? Oh no, that's odd. That just had a cmunch -6 -32. Oh, that's because it's header generation. Header generation doesn't actually matter what version of the architectures it's using. And then build the 32-bit version as well. There we go. And then move RM, copy these modules into the 64-bit status repo, which we can then bounce into. cd /projects RISC OS64 status. So this is the status repository that I keep that says what state we're at. Oh no, I don't want to be in rough plans. I want to be on master. So the rough plans branch has got a whole load of notes about where I'm going with this, so anybody can see it, but it's not ready to go on master yet. Right, so this is all up to date, and we can actually edit the README. Debugger. Debugger is functional. Yes, it is. And functional and decodes ARM, thumb, and AArch64. Not completely finished. No, that's not true. It says it's functional. It doesn't say it's complete. All right, so there we go. That'll do. Commit that. Updated debugger with the new support for AArch64 disassembly. AArch64 disassembly uses Armadillo, and at the moment it seems to disassemble okay, but some instructions came out wrong. Maybe a memory lifetime issue. Memory lifetime issue, I mean, is it done yet, says Dave. Memory lifetime issue means I may have allocated something on the stack and then returned it, or freed memory and then returned it. Dave says, is it done yet? Nearly. I've got AArch64 working, I've got ARM working, I've got thumb working. It compiles kinda in 64-bit, needs some work, and it compiles in 32-bit. I'm just publishing the binaries to the repository, to the RISC OS status now. The output isn't formatted, and the output and the mnemonics are not capitalized, but it does seem to do the job. Bob on. Disassembly just looks wrong however I spell it now. Dear me. Push. There we go. So we go over here, RISC OS64 status. Here's where we've got the modules, so you can see the 64-bit debugger module updated 2 minutes ago, and the same goes for the 32-bit one. Anybody wanting to try them out can download them and run them with Zap, and it should work. And we should be able to see that the status has also been improved as well. Find debugger in here. Where is debugger? I'm going to look for it. Debugger. Why are you not finding it? There it is. Yeah, debugger, functional in 32-bit and 64-bit. There we are. Okay, I think that's been a pretty good day. We have produced an integration that looks like that, so it's much more organized, and with some small problems that we're going to have to investigate next week. It's pretty much working. I am very happy with that. Thank you very much for watching. Next week we will look at debugging what's wrong with Armadillo, and hopefully by then I will have got the source code build system working properly so that I don't have to copy around those headers that were being painful. All right, thank you very much again. We'll see you next week if you want to come along. Please enjoy and keep cool. I don't know about you guys, but it's very warm here. See you later. Bye.